So this was the physics public lecture that we had to do. So the video that I chose was titled Planet 9 from Outer Space. It was a lecture given by Konstantin Batygin from the California Institute of Technology, and it took place on April 9th, 2019. So some of the main points that happened in the video was when we looked at most of the orbits, we were talking about planetary orbits and how they're all affected by gravity. So like basically the object, it has to come back to where it started, or like its initial state. One of the examples given was Sedna. That was an example of how it like orbit was so elongated, but was not affected by Neptune in any way. So there had to be like another explanation, which is where the gravitational force came into play. Another main topic that they spent a lot of time talking about was how we found more efficient ways to get these answers to our questions. So now going back from 1800s to modern day, we have now had computational models which make it faster and more efficient to kind of like view predictions and analyze data. And one of the third main ideas was that they were studying the past different orbits in the Kuiper belt, and how they're all different sizes and at different angles. So they definitely spent a lot of time, kind of trying to break these down using formulas and computing different things to try to make sense of why these orbits are different. So now for the stuff that I learned, a lot of the stuff was really interesting. So I always knew that Pluto was kind of annexed from the planetary system, but it was I just learned that it was in 2006 by the IAU, which I think was the International Astronomical Union, if I remember correctly. And then another thing was that only one planet has never been discovered through regular astronomical steps, which was found in 1781. That planet was Uranus. And Uranus was actually, so when people were calculating the position of Uranus, it was not in the position that the data calculated, like the calculations were off. So then someone made a hypothesis that, maybe the data was wrong. So it was like the orbit path, as well as that like physical position were slightly off. So now the man who was credited with the mathematical discovery of Neptune was Leverrier, if I'm pronouncing his name correctly. So now he made these mathematical equation to help predict location as well as orbital path. And so when he did two predictions, he predicted the first time position was off, orbit was off. Then they predicted a second time, and the position and orbit were off even more. So I didn't know that this was the man who was, the one solving for Neptune's physical location. And another fun fact that the professor said was that actually Pluto's size, the total surface area of Pluto, is roughly equal to the total surface area of Russia. So if you put Pluto inside of Russia, it would fit. And it was kind of funny because at first when they discovered Pluto, they said it was like 400 million miles away or something like that, but it was believed to be bigger than Jupiter when they first solved it. But in reality, it can fit inside of Russia. And there were a bunch of websites saying that, Planet X, it's like the mysterious white sphere in the sky, and it could be dangerous. It's going to come, destroy the Earth by Christmas time. But I mean, obviously it never happened. But there's just a lot of hoax and hype and stuff around it. And towards the end of the lecture, they had some crazy math equation on the board. This was when they started talking about how we switch to computational models nowadays and have computers and make everything efficient. But beforehand, the equations they used were crazy. There were a couple topics that were sort of reviewed for me. So when they talked about the Kuiper belt, when the object said had determined orbits, I've heard that before, as well as Pluto being an icy planet. And then also how we're using computational models to like figure out modern problems and like answer our questions and stuff. So I'm very familiar with that. So those weren't really new topics, more of like the interesting topics were how like people can calculate the orbit of a planet that they've never seen before, never heard of before, just like new information. Um, Now to kind of like expand on one of the ideas, when they were talking about like the computational models, I was like, it's actually crazy how much we use these computational models, or like smart technology. Like think about how much like we all use that. So like you have your phone, your computer, your television, control panels at your house, and anywhere, like thermostats. So now if these were not put in place, like just imagine how much harder everything would do or be to like be able to do the same tasks. So this is kind of the same way in solving for these planets. Like we've evolved so much, so like technology have evolved throughout time, and it's like keeps being advanced by different individuals. Um, but yeah, so that was just super interesting how you could like take that one piece that's able to solve for these planets and like expand it. Like okay, look how it actually affects the entire world, because our world would be insanely different if we did not have these advancements in technology. But overall, it was a really interesting video, really interesting lecture. I'm glad we don't really do much with space a whole lot every day, so it was an interesting video. I'd recommend watching it. I'll see you guys.